You now know how to write and how to deploy Soroban smart contracts, but we are missing one key item that we need to learn. How can we connect a Soroban smart contract to a web front end so that users can interact with a decentralized application?
Net to dev.
We are going to be building a web application that users can access and vote. If you remember on video number 1, we wrote a smart contract that allows users to register votes. One great use case will be for a DAO, a decentralized autonomous organization. Let's say we need to provide users rights to vote. So that means that the user must submit their vote, and we got to register those votes in a smart contract that we can then use and reference to confirm if a proposal has been approved, has been accepted by the community. So let's put it to work. We are going to grab the vote smart contract and we are going to be connecting that on a web front end. The user is going to obtain the Freighter wallet. This is the Stellar's browser-based wallet that allows connectivity and allows interaction with the Soroban testnet. After the user has connected, we are going to obtain the information regarding a particular proposal, and we will show the stats of that proposal. How many voters have voted yes or selected yes? How many voters have chosen no? The amount of votes, how many votes have been distributed between the two options that we're going to have available in this application, in this smart contract. And we will provide the capability to the user to connect their wallet and initiate the session with the smart contract. And after that, we are going to make sure that when the user connects their wallet into the application, the user hasn't voted already. And if the user hasn't voted already, we will provide the buttons that will allow the user to choose the option that they want to vote. Okay. Once the user hits the vote option, the Freighter wallet should pop up asking to sign the transaction. The user is going to sign the transaction. We will provide a model that is going to show that the transaction is being executed. Once the transaction has been confirmed on the blockchain, then we will show that the vote was successfully recorded, that was successfully registered on that smart contract. You need to understand how are we going to do the Freighter wallet interaction with the web front end, and also how can we make calls into that smart contract and obtain the values and show the values in the web front end. We are going to be building a NextJS application. We will install the Stellar SDK, and we will also install the Freighter SDK so that we can connect and make calls to the Freighter wallet. We will modify that smart contract to register votes against the wallet. So the moment that wallet or that account interacts with that smart contract, I am going to be grabbing the wallet address or the account address. I'm going to be registering the votes against that account. What we are going to do with that, for example, the voter has already voted. I will be querying the votes for that particular account ID. We will obtain the values, and if the vote was already registered, the application should not render those buttons. Instead, what is going to show that wallet already voted and the vote choice. What was the option that that particular account voted in the application, in the smart contract? Let's go ahead. Let's start by modifying the smart contract. Let's deploy the smart contract back onto the testnet because we need the address so that we can connect the smart contract to the web application. We'll deploy a brand new NextJS instance and we will build the front end and we will start making those calls. Alrighty, let's go ahead. Let's make it happen. Let's grab the vote smart contract that we wrote on video number 1, and we have to make a couple of changes. One of the changes that we have to do is that we need to allow the contract to store the votes related to the wallet, the user that is performing that vote. We have to use as the parameter index the data for that particular voter. So let me go ahead and modify the smart contract that we wrote in video number 1. By the way, if you don't have this smart contract, you can head to the GitHub repo and we should obtain the smart contract from the Solidity to Rust Soroban Smart Contracts repo. Now, let's go ahead and take a look at that smart contract, right? So we are going to copy the smart contract. I'm going to paste it right here. This will be the smart contract, okay? In order for me to work with addresses, I have to import the macro address, okay? With this, I can then start referencing the user accounts to the struct. Okay, so we are going to be doing the mapping per address instead of the string or the symbol that we were using on video number 1. I am going to do the following. I am going to remove name. Let me zoom in a little bit better. Okay, I'm going to be removing name from the record because I am going to be indexing this information with the address. Okay, so I don't need to show the name. So now I don't need to now pass the user itself. Okay, I am going to pass when we vote, when we execute that vote function, I am going to be still passing that user address, but instead of being a symbol because it was just a string, now we are going to use address as the type, okay? It's very important. I don't want to allow random amount of votes to be registered on the function. Instead, I am going to record 1 vote per wallet, okay? So I don't need to pass a vote value. I am going to confirm that votes, it's always 1 because we are just going to allow 1 vote. So let me define this here. I'm going to say let votes because I still need to provide that. And we are going to say U64, and it's always going to be 1 vote. Also, I want to leave this in caps, the answer of yes to be in caps. The user doesn't click yes, then it's going to be an automatic no. I need to also make sure that this is case sensitive, so I have to make sure that I'm passing the value in uppercase, okay? So I gotta make sure that that's the case. Now, very important, we are now going to be indexing that struct, that information based on address, okay? Which means that I have to use address here instead of the symbol, okay? Beautiful. I believe there's one more thing that we have to work with, which is going to be the view, okay? So now voter is going to be address, right? It's not going to be a symbol. We're going to pass the address of that wallet as the argument to then get the information for that voter. And now I don't need this here. We are no longer storing that name. Yeah, that should be it. And I want to make sure that I registered the vote by authenticating that particular user, which means that I have to do this. I have to do user and I have to require auth. Okay, I'm going to do require auth, and that allows the smart contract to authenticate the wallet address against the session that has been signed, the transaction. Okay, so the transaction, when that transaction gets signed, I have to make sure that the value that is being passed as the user is the authentic value. It's not like anyone can just go ahead and type an address value and pass it, because then anyone with multiple addresses, they don't necessarily need to have a wallet. They just need to have addresses that you can pass that as an argument and then vote, right? But with this, I am making sure that the execution is incoming from the actual user that is passing that value. It's very similar in Solidity when we do a require and we type message sender. This is kind of similar, okay? And we no longer need records name. Okay, now what I got to do here, I have to, instead of me passing this log, I'm storing the values in the smart contract, which means that we are going to be adding instance here. And also, this is very, very interesting. In Stellar, in Soroban, we have to make sure that we refresh the TTL, or the time to live smart contract data. Needs to be refreshed. I'm not going to say refresh. We need to make sure that we tell the blockchain that this data should remain. Else the blockchain, as an efficient way of clearing out unused or stale data, they're just going to purge that data, which means that if this smart contract is going to remain active, we should not have a problem in maintaining the state of the data inside the smart contract. Else it's just going to be purged. It's going to be clean. So what I got to do here, I'm going to say storage, right? And we are going to say instance. And now I have to extend that time to live. So every time that someone hits this function, it's going to reset that counter, okay? So it's going to reset the counter. And as long as people are calling this function, we should be fine in maintaining the data in the smart contract, in the blockchain, okay? I'm going to say extend TTL. We'll pass this value right here. I have to also find a way of returning an acknowledgement. How can I return the acknowledgement? I can say record it, for example, and I can pass or return this value as a symbol, for example. So I am going to say it right here. I'm going to say this will pass a symbol. Okay, so this will return, this function is going to return a symbol. And what I can do down here, I can say, well, symbol short, let's use symbol short. We are going to say record it. Okay, awesome. Okay, so with this, I am guaranteeing that I'm going to be storing the data on the smart contract. And every time that someone calls this function, it just refreshes the TTL, the time to live for this particular data that gets stored in the smart contract. I am going to grab everything, Control C. Let me head to okashi.dev and let's paste it and see if it doesn't throw any errors, and then we'll deploy it. Okay. I just did a new project in okashi.dev, test it out. Okay. So I'm just going to compile, make sure that there's no errors. Okay. Awesome. Okay. So I got the smart contract here. What I'm going to do, I am going to take opportunity of the existing environment that we configured, that we created on the last video. I'm going to be deploying the smart contract just by compiling it, recompiling it. So all I'm going to do is I'm going to paste and I'm going to save, and we are going to do the checks. Let me log in into my machine. Soroban contract build, and it's by default going to check in the contracts folder. We have the new smart contract, and then it's just going to compile that. Okay, go ahead and do that. We have an error. I thought I fixed that, but let me fix it real quick. So probably it's going to be here. There we go. Awesome. So I'm going to save it, and cool. That did it. Awesome. So we have the smart contract compile. Let's optimize the smart contract. So what I'm going to do, I am just going to use the same Hello World project again, but the smart contract is definitely different. It's not the same. So let me go ahead and optimize Soroban contract optimized. Then we point to that compile version with the WASM target and then the file. Okay. So we're going to do this. It has been optimized. Now let's deploy it. We're going to input Soroban contract deploy. Then we point to that compile file and we go ahead and point to the identity net to dev, then the network testnet. Okay, so we're going to press enter. Wait, we should have a smart contract address. There we go. We have the smart contract deployed. Awesome. So with this, I can go ahead and start working on the front end. Let's go ahead and let's build the NextJS front end, and we'll go from there. First things first, I am going to be adding all the styles and the package JSON that includes all the dependencies that we need to install. And all we have to do is do npm I. So let me go ahead and do that first. And once we're done with that, I am going to start writing the functions to start showing data, to start pulling data and rendering data in that front end. Okay, so let's get started. Okay, first thing I'm going to do, I'm going to create a folder. It's going to be styles. It's going to add the file. Again, I'm not going to go on CSS styling. I'm going to save that. Now I'm going to do another folder. This folder, it's going to have the public images, all the animations and all the logos and all that. Okay, so we can render that information using HTML. Quite a handful of animations that I did on this project. Okay, so there's one that says connected, that basically shows connected with an animation, those letters. Same with connecting, executing. So what we're going to do once we start interacting with the application, we are going to be showing that display in the model. So there's going to be a drop down model that's going to show that animation going on. Next thing that I got to do, I'm going to create another folder. This is going to be pages. Create a new file. Let's call this package JSON. Okay. What I'm going to do, I'm going to bring all the dependencies and everything that we need in order for us to build, initialize this Next.js project. So let me go through it very quick. So I labeled this to be DAO. This will be the name of the project. I want you to pay attention to this. There is the script. When we type npm run dev, we are basically executing this. So we can say run dev, run build, run start, and all that. I placed experimental HTTPS under dev. So when we type npm run dev, this will generate some self-signed certificates. And the reason why is the Freighter app, the Freighter wallet, requires an HTTPS session. So it has to be encrypted in order for us to make calls to that wallet, which means that the project must have a signed certificate. I am using a self-signed certificate because this is auto-generated the moment I apply that experimental HTTPS command under that script. But ideally, we want to have a real signed certificate for this, okay? Now, once I've done this, I'm going to save it. I'm going to head under the terminal and we're going to go ahead and run this. Terminal, I'm going to type npm I, wait for that. Cool, we are done here. Now, one last thing, it's going to be the Next.js config. I got a default one that I used that it's for development purposes. Next config JS. All right, I'm just going to paste that in. So we are set here. Okay, awesome. So now what I'm going to do, I am going to initialize this project by creating a file called app.js. So this will be passing the props, the component, and then from there we can start working with the index.js. Also, I am using Bootstrap CSS. Okay, so I am going to let me talk about the package JSON real quick. So I am using Bootstrap for styling. Again, you might use Bootstrap, you might not use Bootstrap because it's an old styling framework. This is for me to build a demo app, so I am just using Bootstrap. Okay. One thing that I want to show you is that I am installing the Freighter API. This is the SDK to interact with the Freighter wallet. Okay, and also I am going to be installing the Stellar SDK. So make sure that those two dependencies are installed. Obviously, if you have the package JSON with everything predefined like this, it's just npmi and off you go. You don't need to do anything else, okay? But just keep that in mind, okay? Make sure that you have those dependencies because they're mandatory. Let me go to app, and what I'm doing, I am importing that prop style. I am bringing this prop style so that we can render the page, and with the styling that we want, and we are invoking the bootstrap, okay? Now let's build an index.js file, okay? This is where all the magic is going to happen. So under index.js, I am going to build that HTML page that is going to show the entire page, the entire site. But before we work with index.js, let me build a page that is going to have the proposition data. That is all the information related to the prop description, the prop title, all of that, because we are just going to tell index.js to look for that information so then it shows that data on the page once it renders, okay? So let me go ahead and do that. I'm create a new file. Actually, I'm just gonna make a new file here. I'm gonna say prop data.js, okay? Inside this prop data, we are going to be creating those variables that will hold those attributes, okay? So bear with me on this one. So the first attribute that I'm going to be showing on the page is going to be the description. That whole paragraph that you saw at the beginning of the video, when we open that voting app, it's going to have the title, it's going to have the proposition ID, the title, and it's going to have the description. We are going to write the description here, and we're just going to pass that into HTML. Now I'm going to make another variable. This variable is going to be called choices. This is very important. So this array is going to hold two strings. One string is going to be yes, the other one is going to be no. This is the same information that I'm going to be showing on the buttons. So when we render those buttons, I'm going to be showing exactly this string. This is also the same information that I'm going to be passing when I do my calls to vote, to record the vote. I am going to be passing exactly this value right here. When the user clicks, that value will be passed onto the smart contract, okay? Next, I am going to be adding additional details into the page. So basically the title, the ID, this is for me self-made. This is a demo, okay? So you could come up with an ID generator of some sort that every time you generate one new prop, then this ID will change, and then you can reference those IDs to the proposition in case someone needs to look for those props, you can do so, okay? This is, in my case, my goal is to show you how can we interact with the Soroban environment on the front end, okay? Start date, this will be the date that this prop starts and the end date. Another also suggestion will be to add a timestamp to the call inside the smart contract, so then you can use the timestamp as the date that was open, the proposal was open, and then you can say if the timestamp to vote is higher than what you specified, then don't allow to vote. That is a good way to close the voting poll. Okay, and then finally what we're doing, we're exporting this. Okay, so let's go ahead and export all of that. So I'm going to be passing this here, and that should be it. Now with this file, all this information, I can call those values and pass them on the HTML section, and I can show this in the front end. Okay, so now let me go to index, and the first thing I'm going to do, I'm going to import those variables. I'm going to say description. I am also going to be working with hooks, and this hook will be use state and use effect because we have to do some magic with that. I have to store values as I am calling functions and obtaining information from the Soroban contract. I want to store them in that state, so then I can pass it to the HTML object and show the values. I've done so many projects on this channel regarding Next.js, so you should see a couple of good ones that I have. I'm going to also provide the links. If you want to know more about Next.js, I suggest you watch those videos. It's literally directed towards a Web3. Okay, I think that's it. Oh, I have a font, so I'm just going to use the SF font. I like to use that font. Okay, this will be just for styling. And yeah, let's start coding. So I'm going to say export default function, and let's just call this DAO. Okay, let's make it happen. Okay, let me go ahead and pass first the HTML so then you can at least see what we are going to be working. So let me see here. I am going to be passing a couple of things. Okay, so the first thing that you can see right here, this is the model. And by the way, I'm going to do the following. I'm going to remove it, and I am going to work on the model once we are ready to display information on the model. Okay, I'm going to save that, and I am going to confirm that all this information, all those variables, I am pretty sure that we are obtaining that from here. So right now we are missing the following. You can see prop title. We are passing prop title. This will be at the upper left corner of the page. We're passing prop title. Prop title is what we stored in that prop data.js file that we just did, and all those attributes. Okay, so choices, I am not passing choices because that will be used in functions. Okay, so we're going to go through that in a second. So start date, that's good. End date, good. Okay, prop ID, description, all of that is something that I've been passing. Connect wallet, this is something that is going to error out, which means that I'm going to remove it. And also connect is going to be a button that changes its state and shows connected once the wallet gets connected. Okay, beautiful. Also, I'm going to be providing that public key because I want to also show that the user connected with X wallet, so they know that this is the wallet that is interacting with the application. And that's it. So I have to build some use states and I have to pass some default values. I'm going to be passing a default value to connect. I am going to also be passing a default value to public key just to test, to make sure that this application renders. And then we can focus on the Freighter wallet and we can focus on the Soroban calls. Okay, so let me go ahead and do that. Just want to make sure that we have the front end ready to go. I'm going to be passing two use states, right? By default, public key and connect, you can see it right here, are going to show once the page initially loads, it's going to show connect and wallet not connected. Okay, so if I don't connect my wallet, it's always going to show that in the front end. Okay, we're going to see that in a second. I am missing total. Total is something that is not defined in prop data, which means that I have to build another use state. So let me take the opportunity to do this. Here, I'm going to say constant get total, right? I'm going to specify total here. And now this will be a number, obviously. This is going to be a number, right? So for now, because nothing is connected, it's initially going to pass 0. So that's the number that we should see as the total in the front end. So I'm going to save this and let's see if we can run this. Okay, so I'm going to type npm run dev and you should see a self-signed certificate being created, right? Because we specify experimental HTTPS. So this is why I told you that this is needed in order for us to interact with the Freighter wallet, okay? Which means that now I should be able to access this through HTTPS, which is what we're going to do now. Let me open the site. So let me give you an overview. This is literally being pulled from that prop data file. So I'm going to show you the prop data. Okay, so the prop title is what we see right here, build a community DAO on Soroban. We can see it right here. The prop ID is being passed right here. So if I show you how do we pass that, it's basically adding those strings. Okay, so I am going to go back here. It should be proposal. There you go. So proposal, then pound, then prop ID. That's the prop ID that we're passing from that file, and then description. Okay, and description. This is the entire description that we have, and then the subtitle. Okay, so if we go back, there we go. If we connect, right now, this button is not attached to anything, which means that once I click it, nothing will happen. We can see that nothing happens, right? And by the way, we can see total vol zeros. This is the state, that use state that we defined, right? So if we go back here, we're gonna take a look, get total and total, because get total is not being used, that hook is not being used, then we're passing 0. And then wallet not connected. We are not seeing wallet not connected, I think because, oh yeah, we can see it. So by default, it's going to show wallet not connected. So we have this ready to go. Now I want to interact with this button, so then we can at least see that the button is passing some arguments, okay? And we can capture the state and we can update the state and whatnot, okay? So with that said, I am going to create that function to connect, okay? So let's go back and I am going to define that function here. It's going to say async function connect wallet. And now inside this connect wallet, I am going to update the state. Okay, we're going to say get connected. That's the first use state. And we are going to pass. Let's imagine that we are hitting that button, right? Everything went well. I'm going to say connected. Then what I'm going to do, I'm going to say get public key. Okay. And just to test, I am going to be passing anything. I'm just going to pass A, B, C, D, E, F, G. Okay, we know that that is the quote wallet, but we want to test and want to make sure that the button is working and all that. Okay, so the button is right here. If we take a look at the button, you can see that I did a style, like this is the color similar to what we have on the Freighter wallet site. Let me show you. And basically this is the color and whatnot. So I tried to mimic the button with this logo and everything. Okay, cool. So you have it right here. Now, if I go back, I am going to attach that function, declare right here in that button. So I'm going to copy that name. I'm going to go to the button, okay, on click, and we are going to define this to be button to connect the wallet. I'm going to save and let's take a look. Look at that. So it changed to connected. Now we can see the wallet, quote, wallet address. So we now know that everything's working as expected. Okay, awesome. Now the next thing that I'm going to do, I am going to be working on the proposal voting stats. I want to test that function by just passing values as yes or no. And then we should be able to see the percentage. Okay, let me test that out. So then we can go and focus 100% on the Freighter and the Soroban interaction. Okay, so let me fix that. I'm going to add that information here just as a mockup. Let me go up. Let me show you real quick. So I'm going to be writing that function. It's going to be called async fetch votes. Okay, function fetch votes. Okay, there we go. And now let's do the following. I am going to define values. This will be the vote amount. The idea is to obtain this from the Soroban contract once we call view poll. We should be obtaining the amount of votes, amount of yes, amount no, and the total. Okay, so what we need to do for now, just to validate that the front end is working, is to simulate those values. Okay, let's say 7 people voted yes. This will be the first value in the array, and then no, let's say 4. Okay, this will be the values, and then we are going to say let total. It's going to be what? It's going to be values plus values 1, the first and second position on that array, right? Okay, that should give me total. Now what I can do here, I can pass the total to the state. Okay, so to get total, so then it shows on the screen on that section where it shows 0, because we're just passing the default value. Now I should be able to update that. Get total, right? And we are passing total. But now what I want to do is that page gets loaded. I want to run this. I want to auto run this, right? So I can say use effect. I can do use effect. This is one way, okay? Because we want to make sure that it's a conditional rendering. I want to say if total is equal to 0, then that means that you haven't loaded that function votes, okay? And I am going to just pass empty for now. The moment I render this page, it's going to check if total is 0, right? Then run this, which means that it's going to run this value and show the page. And this is just for us to test. I'm gonna save it and give it a shot and see. We can already see that we have 11 votes, it's 7 and 4. Okay, that looks good. All right, so let's build this function. So I'm gonna say let container, right? So we have to capture the DOM element. So I am going to be interacting with the JavaScript DOM, okay? That allows me to dynamically update HTML objects. This allows me to add HTML attributes dynamically. So let's say we voted, someone voted in the application, then we want to make sure that we can capture the existing HTML and update whatever the field is. In this case, we are updating the bars that are going to show the percentage allocated to yes and the percentage allocated to no by doing a percentage formula, then passing the value as the HTML attribute, okay? So I'm going to say document get element by ID. I'm going to show you where this element is located in the HTML object, because obviously we are getting that element by an ID, from an ID, which means that I have to have this already rendered in order for me to obtain that, okay? So I'm going to say choice container, and I'm going to show you where that is. Scroll down, okay? So scroll down, and we can see it right here. Okay, so what's going to happen? I am going to be grabbing the DOM element for this ID. I'm going to be grabbing that DOM element, and I will be manipulating that element. I can create other elements inside this div without actually having to do this manually in HTML. And ideally, that's what we want, because this is constantly going to change. This is not going to be a static environment. It's going to change values. People are going to vote, and those values will be updated. The same goes for the buttons. In order for me to show the vote buttons to a voter that hasn't voted, but not show the buttons to a voter that already voted, I have to do a DOM manipulation. I have to make sure that I can provide that change or that dynamic update in the HTML rendering component. Okay, beautiful. So with that said, I am going to head back. So I should obtain that container element right here. Now I can work with that. Okay, now we're going to say for, I'm going to say let's do a quick loop so that we can identify how many people have voted for yes, how many people have voted for no. So all I have to do, I have to find the length, in this case, the amount of choices that we have, and then we can iterate and use a for loop to get for yes, get for no, okay? So I'm gonna say for let I equals 0, I, it's then what? Then choices. Remember choices, that is the choices yes or no. So we have only 2, okay? So I can either do that, or I can just say number 2, and that also works, okay? So I'm going to say length, should do it, and I'm going to say I++. Now, with that, I am going to say let choice count, okay? What is this? This will be the amount of votes, because we're passing values for the first option. Remember, we are passing choices. So the first choice in that array is going to be yes, and then the second choice is going to be no. So we are iterating every choice count for yes and for no, okay? We are going to grab the values for both. Now we're going to say choice description, right? We want to obtain what the description of that choice is. In this case, yes or no. That's going to be the string value, okay? So we're going to say choices, and we are also passing I, because then we are going to get, the moment it does the first iteration, it's going to grab value 0, which is 7, and that option and choice is going to be yes, okay? And then we will continue. Now we are going to say choice count, okay? if choice count, which is what we obtain here, it's 0, right? What do I want to show? I want to show the percentage for either yes or no to be 0, okay? So I can do that. I am going to be creating another div element, and I have a great video showing you how to work with JavaScript DOM. The link on that video below, it has everything. If you watch that video tutorial, I am guaranteeing you 100% that you are going to be very proficient in working with DOM manipulation, okay? I'm going to say div2, and now we're going to say document create element. Now we can append an element to that existing ID, this particular container that we just grabbed right here, or this div, okay? So we're going to say create element. What kind of element am I going to create? Create another div. So we are going to be creating another div inside that existing div. And now we're going to say let HTML2, and this is a way for me because I know which div am I creating. This is div2. I could say div1. Div1 is going to be when there is a vote, there's actually vote numbers, going to use div1. It's just my way of labeling things, okay? So I'm going to say HTML2. And now we are going to be passing this. And as a matter of fact, I can just copy it to be faster. I'm going to show you what this is all about. What's happening is this HTML object is going to be created and it's going to pass the description. This will be either yes or no, depending on the loop. And then the choice count. This will be the amount of votes in that array, right? And then by default, it's going to show 0, meaning that if this choice counts 0, then it's automatic a 0%. Else, we are going to be doing the math, okay? So bear with me. Now what I want to do, I want to say div2, right? Now we are going to enter HTML, and this is how we append that information. We are going to say HTML2, and that should be it. Next, by the way, this should be here. Div2, now we are going to say container. Now we are effectively appending that. Append child, and this will be HTML2. Right, so we have appended that. Now we are finally grabbing the one that we have manually defined in the HTML code and appending HTML2. And I want to do a break. So I want to just break the space between yes and no, so then it's not all together. So this is more like styling more than anything. So I can do container, append another child, but then I can create one on the fly. So I can say document create element, and this will be the break element. It's just BR, that's it. Okay, beautiful. So this should provide me, and we can test it out, by the way. What I'm going to do to see if it works, I am going to save this, but then this should be 0 because that's the only condition. If this matches 0, then it's just going to show that. I'm going to paste it for both. Boom. And if we take a look back and we render, argument 1 is not an object. So let me take a look at that. So it's not HTML2, it's div2. I got to pass div2 here. So let me fix that. Okay, so I'm going to say div2. Save it and take a look. All right, awesome. So now we can see that it shows yes, no, 0, 0, 0 because we just modified that. Okay, so now I am going to do the same thing, but now we are effectively passing values. Okay, so now instead of this, I am going to actually do the entire formula that will show the bars. What we're basically passing is going to be the value as the width, and we're just going to paint that with a background color. The width is going to be defined by the percentage, and we're just painting that line. It's kind of cool. It's a very simple way to do a percentage bar. If this matches this, then else, now we are doing the magic. We're going to say let choice percent. This is how we obtain that percentage. What we need to do, we are basically saying 100 times the amount of votes that either yes or no received. Then we are passing divided by total, right? By the total amount of votes. And we want to delete anything after the decimal. So then it only shows the last 2 decimal places. So it's going to be choice percent. It's going to show me the percentage, okay? Then now we are going to be defining 2 div elements. Let me just copy and paste to show you faster. Okay, so this is the first one is going to be div1. We're going to create one element, div1, because now I cannot make both of them the same. I have to make them individually because one is going to be yes, one is going to be no. In this case, they both had the same value. It's because both of them were 0, okay? But now this case is going to be different. What the magic is all about here, okay? So div2, when we create that element div2, we are passing this as a bootstrap styling to build that progress bar. Y0 progress bar, this is all styling. And then we have the background. The background is going to be the color of that bar. then alignment is going to be aligned to the right. Then the width, okay, so what I'm doing is I am passing percent, okay? So we're passing percent divided by 4 plus REM. And the reason why I did this is because of the format, the syntax, it was not going to align with the bar where that bar is going to be contained. The card object that bar is going to be contained inside was going over. If it goes to 100%, it was going to pass over. So I know that I can do some padding and whatnot. Again, front end is not my thing, but with this, I can make sure that it doesn't go over the card box, okay? And we are passing choice description. I got to fix this right here. And choice count. So I am passing the amount of votes, HTML1, HTML2. So HTML1 is going to be the yes and the amount of votes, or no, the amount of votes. HTML2 is going to be the actual percent, and it's all going to be painted with that div2 because we're passing div2, which will add the background color and all that. So this is how we're doing that percentage bar. And once we do that, we associate that inner HTML to those objects that we just did, and we have to append them. We have to add them onto the container, right? And we are going to be append child, and this will be div1. Let me not make the same mistake that I did not long ago. Container 2 is going to be append child 2, div2, and we are going to make another break. Okay, so then it has some space in between. Very straightforward, okay? Now, I gotta make sure that this is not enforced. The reason why is because total is gonna be more than 0. And if it's more than 0, it's not gonna render this fetch vote. I got to do this. I'm gonna pass, once again, the same values as I passed before, but in this case, I'm gonna pass 7, I'm gonna pass 4, right? But then now I'm just going to remove that condition. If everything goes well, we should see the bars. So I'm going to save this and see that. And there we go. Awesome. We can see right here a distribution of votes. So we have yes, this is the bar, and the bar has been painted with the background that we define, that hex value that we define right here, in the background color. That is the background color. And the width is going to be that formula that we did, choice percentage, as REM divided by 4. So this is a way for me to build a width to define how long is that bar color going to be painted, which is basically the percentage that that vote has, okay? Which is kind of cool. So you can see here 63 against 36. If I, let's say, change the values, I'm going to put different values, right? So I'm going to say 8. And we're going to say 24. Okay, so this is a considered amount. I want to say save. I want to check again. There you go. So now we can see that yes, it's 25% yes, no, 24%, 75% with a total of 32 votes. We are 100% golden. Now it's the fun part. Let's start working with the Freighter wallet. The Freighter wallet. Okay, so we are going to install the Freighter wallet as a browser extension. We'll register the wallet. And once we are done, when we initially create the wallet, and the moment we obtain that wallet, we can fund the account with test tokens, because again, in order for us to have this account active on the blockchain, we need to fund. Once we get that, we should obtain the tokens that will allow us to interact with the smart contract, and there we go. So we have the account. Now the next item, let's work with the API. So the Freighter API, we basically install that in the NextJS instance. We already did it with the package.json. All I have to do now is interact with the interfaces. So we are going to head to using the Freighter in a web app. Okay, so we are going to click here, and basically it's giving us functions that we can interact with that Freighter wallet. Okay, so this is what we're going to do. We're going to do the function that will allow the connection to happen. It's going to trigger the connection to the wallet, then another function that is going to retrieve the public key, because we have to be sending that public key when we request the votes as well as when we register on the app. So then we check if that wallet already voted or not. Okay, and finally we will do a last function that will sign the transaction. It's very important for us to build that transaction. If you remember on the second video, build that transaction, then we encoded that transaction in XDR. Now, instead of us having the secret, we're now going to be interacting with an external wallet, which means that I have to sign the transaction using that wallet and then send that transaction to the blockchain. Okay, so what I'm going to do, I am going to be creating 3 functions, one to enable the connection between the wallet and the web application. The second function is to get the public key, because we're going to be passing that as an argument when we vote or when we initially log in onto the application to confirm if the user has voted or not. And finally, we will sign the transaction. So we have to do all three functions. Okay, so let's go ahead and do that. All right, so in my project, I'm going to do another folder. And let's call this folder components. Okay, expand a little bit here. There we go. Okay, awesome. Inside this components folder, I'm going to do another file. This file is going to be freighter. Yes. Okay, let's work. So if we take a look at the documentation, we are going to be interacting with is connected, get public key, and sign transaction. So those are the items that I'm going to be importing from the freighter API. And then from there, we are good to go. Okay. So also we're going to be interacting with it's allowed. So let me go ahead and do that. Okay, so I am importing request access, sign transaction, and set allowed. So let's build the first function. The first function is to enable the connection with the wallet. We will create the function, then we'll connect the button. Okay, so we'll connect the button, make sure that the button pops up. So we're going to call async function check connection. Let's just call this check connection. And then we are going to say constant is allowed. This is just like what we have on the documentation. So this is literally me from the documentation. I'm going to say await, and now we're going to say set allowed. Okay, so this is triggering this function that will trigger the connection to the wallet. And if that returns true, right, then we are going to just do return true or return it's allowed. It doesn't matter. Awesome. So with this, I can now export that. So I'm going to say export, and then we'll pass that check connection here, and boom, off we go. So now let me go to index, and let me import it here. I'm going to say import connection, and looking good. Okay. So I am going to be attaching this to the button. Okay. So let's do that. What I can do, remember this function that passes connected, we are going to be adding here before that function. So I'm going to say await, right? Actually, I can say, remember, if check connection returns true, I can use that true here as well, which means that I can say if await check connection, right? Whatever return is, if it's true, then we can do this, right? We want to pass the real key of that wallet. So first, let's test that the wallet can connect, and then we'll modify this because we'll need to do another function that is going to give me the public key. Okay, so let me remove this, okay, and we'll just add get connected, okay? So I'm going to save it. Let me run. Okay, let's give it a shot. Boom, and we got the wallet popping up. Awesome. We're going to connect, and we are connected. Awesome, so that works. Now I am going to do another function that is going to give me that public key, and then we can pass this to the use state so that we can show that the front end. So let's go ahead and do that. Okay, so let's build that function in the freighter section or the freighter file. And what I'm going to do, I'm going to actually copy and paste what we have from the documentation, right? So I think it's request access right here. This one is going to give us that public key. So let's just copy this whole thing and we can export that. Okay, so I'm going to copy, I'm going to go back, boom. Okay, and now I can export that. So basically what's happening, it's going to call request access, right? So we're passing that there, enabling those two vars, so then they will be updated. If this works, just populates with public key, and it tells me the public key. Okay, so I will be obtaining the public key from the wallet. Okay, so I gotta export that, retrieve public key. Okay, so I'm gonna save it. Let me go back. Now I gotta import that here, retrieve public key. And now I am going to pass that argument public key, and I should be able to pass the retrieve public key here, right? So that will be returning the value. Okay, so let me save this. I'm gonna go back, refresh, connect, and boom, we got the public key. Awesome. All right, so the button is working. Now I am going to be doing a function that will allow me to sign the transaction. Okay, from there, once I do that, I can move on to the Soroban JS, and we are going to be building or modifying the contract function, the function that we did on the previous video to interact with the smart contract. But the only difference is that we are going to be replacing the key pair to execute the transaction, and instead I am going to be passing to the wallet this transaction to be signed. Okay, so let's do that. Okay, so let me build one more function, and I'm pretty sure that that also is on the freighter site. So let's look for that. So this is retrieve, get user info, and it's going to be sign transaction. This is what we're looking for. Sign transaction. This is it. This is the one that we're looking for. Okay, so we're going to pass this, copy. And this is in TypeScript, so I will have to modify that to not show the type because this is JavaScript. It's not TypeScript. Okay, so yeah, you can see that it's not a problem. I'm just going to remove the type from here. So I'm going to pass the network and then sign with. So those three arguments I will have to provide. And Boom, and that looks good. Awesome. So we are going to be using this function to then sign that transaction. Okay. All right. So I'm going to save this. I want to say user sign transaction. We will export this. Now this function can be used in the call to interact with the smart contract. Let's work on the Soroban function to make the calls retrieve the value from the smart contract, update the information in the front end with the votes, and also do the vote. Let's go ahead and do that. Before we start coding the Soroban call, the Soroban function to connect to our smart contract, I want to add the model. So the model is basically a pop-up window that will show once we either connect the wallet or interact with the smart contract, we want to tell the user that a transaction is in process or we are processing something in the backend. Let me add the model. This is a Bootstrap model. Okay, so I'm going to add it here. I'm going to copy and paste. This is pure HTML. Let me format this a little bit better. Now that I have this, you can see that this is calling this ID, which we can invoke in the function to do something, right? So I can update that on the fly as I make, if I'm executing any transaction, I can inject that into the model, into the HTML DOM. I am going to pass an image depending on the situation. Like this image is basically an animation that I created, and you can see it here on the public folder. I have a couple of animations that I did in SVG. We can pass that and show that. Okay, so for example, once I connect the wallet, I want to show connecting, and it's until the user hits connect, then it just refreshes the model back, and we should see back the application. Okay, we should see the front page. So let's do something. Now let's add another use state so that we can pass those values into model message. So we are passing that state here that it basically is going to point to those files. Every time that I want to update the model with a different message or a different animation, I can then just pass that as a state, and I can do that. Okay, that's kind of cool. I am going to be passing that. I'm going to copy and paste to make this more efficient. Okay, so I'm just going to do model ms. So I'm going to pass this. This will be the source of this file. I will be updating that as we go. And this is the use state that I will be passing to update this. Okay, so let me go ahead and use this. So the first thing I'm going to try is to update that model when we connect. Okay, so when we connect to the application, we got this connect wallet. I can actually say set model message, and I can pass the file name. So in this case, I want to use connecting. So that means that once the user clicks connect wallet, they're effectively connecting to the application. So I'm going to pass that an animation that I got, SVG, okay? And I am going to open the model. So in order for me to interact with Bootstrap's model, I have to invoke that ID with that Bootstrap model function. So let me go ahead and copy and paste. I'm going to show you what that means. I'm going to just add it here. So to open that model, we just invoke this, and to close the model, we invoke this, okay? So let me go ahead, and this is strictly Bootstrap. This is not related to Soroban. This is in the framework to style this site, okay? Styling is not my thing. Then if the user indeed clicked and connected and we got those values, we can then say close model, okay? Then that should do it, okay? So let's take a look at that. I'm going to Control S. Let me try it. I'm going to refresh, and if I click connect, so if I click connect, boom, there you go. So we got connecting, and we got the model pop up with the SVG animation. Then what I'm going to do, I'm going to connect, and that should go away. Got away, and now we got connected, and we got the wallet address. All right, now let's work in the Soroban JS function to make calls to that smart contract. And let's build another function, or build another file, I should say. It's going to be called Soroban JS. Awesome. So let's start. I need to import the following. I need to work with the Stellar SDK and Freighter because we are going to make calls to sign that transaction. If you remember on the previous video, I worked with the Stellar SDK to make transactions to call the Soroban smart contract. So I am basically using the same. We are going to just copy and paste all that. And what I'm going to do, I am going to be modifying some fields that we need to make changes in order for me to do the calls using the Freighter wallet. So I am going to go very quick on this. If you want to learn how to do the entire function and what happens behind the scenes on every single function code that I'm adding onto this contract interface, you want to watch the previous video, okay? And I go in deep on this particular function, okay? So let me add that there, okay? Beautiful. Now I am going to add two things from Freighter. We are going to be importing that function to sign the transaction. So user sign transaction right here, boom, that's one of them that we just did, this one right here. We are importing that into Soroban, into the Soroban interface, and now we are going to import the Freighter API function to get the public key. So I could do that, or I can just pass the public key here, right? So I can do request access, but I'm just gonna import the function itself. So I'm gonna say import get public key Stellar Freighter API. So now with this, I can pass the wallet address when I make the calls to the contract, to the Soroban Smart Contract, and I can make the calls on behalf of the user. Now we are going to be passing the RPC URL for the Soroban testnet. This is very similar to what we did on the previous video. And we have to store the smart contract address. This is going to be the smart contract that we deployed on the beginning of this video, okay? So let me write it here. So let contract address, and let me find that contract address. And here's the address, boom. Pasted the address. We are good. This is our new smart contract that we deployed not long ago. And one of the things that I gotta import, it's that function. Remember on the previous video when we converted the string to symbol, because we are passing this to be a SC val. We have to encode this in XDR so then we can send that to the smart contract, to the blockchain. So I have to make sure that I do that. But also, I am going to do a new function. This time is to convert the address, the string address, the public key, as also XDR. So we have to convert that to XDR. Okay, so let's do that. This will be constant, and we can call this account to SC val. Same approach. And we're just going to pass account. This will be the string value. When we get the public key, we'll just pass the public key here, and we can convert that to XDR. And we're going to say new address, right? We can say new address. And now we pass account. This will be the value, and we will tell to SC val. Okay, so this is how we convert that value to XDR so that we can pass it to the blockchain. The blockchain is expecting us to pass this value to make the call, to build that transaction. I cannot just pass the string value of the public key because it's not going to let me. And this are params that I got to pass by default. This is part of the call to the smart contract. Again, if you want to learn everything step by step on this particular section, go to the previous video. And now we are left to interact with the actual transaction, the contract, and the Soroban RPC, the transaction builder. Okay, so let's build that transaction. What I'm going to do first, I am going to be bringing the transaction, the contract interface that we built on the previous video, and then we'll modify it, okay? Let me go to my Github Repo. Github Repo, let's go to Soroban. The repo is going to be the EC Stellar Soroban JS SDK functions. And inside here, I'm going to go to interfaces. And this is the interface right here. This entire interface, we want to pass it. Let me grab that, copy, head here, paste. And now let's work with the interface, okay? I want to show you the difference. Remember, previously, we were using the secret to call this contract interface, but now we have to pass the user. So we have to pass this function to the user so the user wallet signs it instead of the private key or the secret, okay? What I'm going to do is I still need the provider. The provider, I still need this provider. I don't need this, right? Instead, what I'm going to do, I am going to be passing the caller. Let me go back. This caller, I'm just going to pass that from the session, from the wallet. Once the wallet gets connected, we can use that public key of the caller and then continue the call. Okay, so I'm going to remove this. Now I'm going to say caller, and we will just pass that from the index. Once we build the function to vote, we will pass that information onto that function. Okay, and now what I can do, I am going to say the following. So I still need to use source account. So what's going to happen is caller, which is the public key, is going to be passed into provider, and then we can use the source account to make the call, okay? This all stays the same. I am not gonna make any changes here. However, I have to make sure the following. We need to make two calls. One call is to obtain information from the poll to retrieve data. So this is to read the function, to view poll, and to obtain the votes from the user. And the other function is to write, which means that I have to pass values. I have to pass that information that we encode in XDR, I have to pass those values here, okay? So I want to take opportunity and use one function to do both things. So what I can say is I can do an if right here. I can say values is equal to null. So I have to make sure that if I want to use this interface function to make calls to read, I will be passing values as null. So then it falls into the read function, okay? So I'm gonna say values null. Then, actually, I gotta do this below here, okay? So I'm going to do that. Then build tx, I got to make sure that I just declare this here without any value. Then if values are null, then I'm going to pass this here. I'm going to pass build tx inside here. right? If values are null, then I don't need to present this, right? So I'm going to take that out and just leave function name. You see where I'm going? So that means values are null. I'm passing that from my call. That means that I just want to read. I'm not passing any values to write, right? But in this case, this is in case the function doesn't require any values, then I can pass null. Then it's not going to pass it to the contract call, right? Instead, it's just going to pass the function name, which in this case is view poll or view voter, and then so on. Else, I definitely want to build that function, that build TX, build the transaction envelope with the value, right? So I'm going to pass values here. I'm going to spread that array, and that should be it. Okay, so now I can use this function to do the things, either read or write, which is kind of cool. Now I got to do the following. I am going to add the build TX. I'm going to add this build transaction here, and then prepare is going to be signed by the user. This is where the magic happens. So pay attention to this one. So I'm going to still use that provider prepare transaction, build transaction. We'll passing that from the previous variable. Then we'll pass the value, whichever value was here. Then what I'm going to do after that, I'm going to say let prepare TX. This is the big change. We have to convert this to XDR. So we have to say underscore build TX to XDR. This is the big change, okay? We have to make sure that we encode this, pre-encode this, because the wallet is going to sign the XDR values. It's going to be a very long value that gets generated out of this call. And now we're going to sign that transaction. What we're going to say is going to say let sign TX. And we can invoke. I'm going to say await. Now we're going to use that user signed transaction. Okay, what is expecting? Remember, it's expecting the XDR value, which is going to be prepare TX. The next, it's expecting the network. The network, it's going to be the testnet. We have to pass this as a string. So I'm going to say testnet uppercase. And finally, sign with, it's going to be the public key of the wallet. So I'm going to pass caller. Remember, when we initially call this function, we're just going to pass the string value of public key. Okay, so once the user connects their wallet, we store that in state, and we can use that to make calls. Okay, once we get that signed transaction, okay, we now can pack that TX, and we can actually do that transaction. Once it gets signed here, now we can build that transaction. We're going to say transaction builder, right? From what? From an XDR value, which is signed TX. Okay. It's going to say sign TX, that's already encoded in XDR, and we're going to say networks testnet. Okay, so we are passing that phrase. It's expected for us to use that XDR from XDR by passing those two arguments, the sign envelope with all the information, the transaction already signed by the user, and the network. So we are pre-signing that. And I don't need this prepare TX, so I can remove that. And now what I got to pass down to send the transaction is that TX. I can say TX right here. I'm going to pass that. That's it. Everything else, it's going to remain the same thing. And after that, everything else will remain the same. No changes. Okay. Beautiful. Cool. So we got the interface. Now we can make calls into the smart contract. I'm going to save this. Now let's use that function that we wrote. Let's first use the function to obtain the values from the smart contract. Okay. So let's go ahead and do that. I'm going to type async function fetch poll. We want to obtain vote status. I can pass the caller. This is the public key of the caller that connected the wallet. And I am going to now store the call into result. So I'm going to say await. And now we are going to use that contract interface. Oh, I forgot this. Await contract interface, right? And I'm going to say caller. I'm going to pass caller again, the public key. Then I'm going to pass the function that I want to use. So if you take a look at the arguments that I wrote, function name. So I have to pass the function name from the contract itself, and then the values if there's any value. In this case, I'm just reading. I don't need to pass any values unless it was like the voter where I do have to pass values because I have to provide the address and whatnot. In this case, I do not. So in my case, I'm going to say view poll. This is from the smart contract itself. I want to pass null because there's no arguments to be passed as far as values, okay? Once we obtain the values from this call, we need to obtain the no, the yes, and the total. Those are the values when we view poll. When we hit the smart contract to view the poll, we will obtain in return the no, the total amount, and yes, okay? So let's store each value individually. But you know what? First, I'm going to do this. I'm going to say console log results. So we're going to do result. And what I'm going to do, I'm going to export this. Okay, so let me go ahead and export this. I'm going to say export, and we are going to export. I'm going to save it. Let me go to index and import that. So I'm going to say import poll. There we go. Awesome. So we have it here. And now we have to fetch the poll. Okay, so how can we do that? We have to fetch the votes, right? So we have this use effect because the moment we render this page, it's going to call this function because of this use effect. I have to await for the user to connect the wallet first, so then we can obtain the poll, because we need to have that connection to the smart contract, right? We have to be able to connect to the blockchain. So we are going to do a couple of changes. I have to determine that the user connected the wallet. One way that I can do that is by making sure that the public key, it's not wallet not connected, because by default it's going to be this value. So I can confirm if this is not equal to this, then that could mean that the user connected the wallet. Okay, so I'm going to say if public key is not equal to this, wallet not connected, that's one way. Then I am going to now, instead of me passing it directly into connect wallet, right? I am passing this right here. I am going to pass connected inside here, right? Get public key, but now I have to make sure that this gets rendered every time that this gets updated, which means that I have to pass public key down here. Okay, so I'm going to say public, right? And now I can pass connected here, for example. I don't need to pass it onto the button. And now I can call fetch poll, and I'm going to say color. Now I can use public key inside here, because I know that the value is going to be the actual public key in string. Okay, let's do that. Right? But before we do that, I want to confirm that I'm going to console the log. So this will be called the moment I render the site and I connect the wallet. Okay, so I'm going to save this. Okay, let me give it a shot and see. I just saved. Let me connect. It's connected because I already have an interaction with the application on the browser. But now it's asking me to sign a transaction because it's going to read that view poll function. I'm going to sign. Everything goes well. Okay, so if I go to the console, we got information here. I got to fix that. Connecting here, I can pass that. I can pass this closed model, so it doesn't keep showing that connecting. I want to pass that model now instead down here, okay? So I'm going to pass it down here, and let's give it a shot. Let's test it out. I'm going to connect, and now it's telling me that it's first time interaction, but it's not. I'm going to connect here. Now the model went away, and now I can sign this transaction, okay? So I'm going to sign this, and that should be good. So let me do F12. There you go. We got the response from the blockchain. Okay, awesome. So now you can see here, let me zoom in. Now what we can see is value. That is the value for each item inside that array. If we look at the smart contract, the values are going to be no. This will be the amount of no, the amount of total, and the amount of yes. What we need to do now is that we have to grab those values and convert that to string. And then we should be obtaining the values. Let's go back to the function. Now what we're going to do in Soroban, now I know that I can obtain those values individually. So what I can do to convert that to string is the following. I have to determine the location for this value. So for example, we got the array, we got those three values, right? First of all, I have to be able to extract that from the object that is being returned. So what I'm going to do is I am going to head here. I'm going to say let no, this will be the no amount. And we can say now result dot what? That underscore value. Remember, we are going to obtain that from value, which is the object inside that return. The object is going to be underscore value. So we are extracting that this way. Then 0 will be the first value inside that array, which is the value of no. And now I can say underscore attributes. How do I get that? If we go here, you can see attributes will be the second value, and then I can find whatever is inside this value. So if I expand this, now it's going to be object, the key, and the value. We are looking for val, okay? This will be the actual amount. Key will be no, will be the object that I'm getting the values for. So let's do that. I'm gonna say attributes. Now I'm gonna say val and dot underscore value, okay? If we go back, let's see if that's the case. So if I go here, val, this is the attribute, and we are looking for value. This is it right here. And you can see 0. So 0, it's the amount of no's. There's no one has voted no. So it's 0. And value, that will be it, okay? So I want to convert this to string, so I am going to enclose this, right? And then I'm going to pass to string, and boom. Well, guess what? The other ones are the same. So I'm just going to grab this, all right? And this will be total. The total amount will be the second value inside of that array. And then finally, it's going to be yes, value number, okay? So we have everything here. We got no, total, and yes. This will be the amount of votes in that smart contract. We should be able to obtain all that. And what I'm going to do, I'm going to pass that out to the front end. So I'm going to say return, and let's just pass it as an array. We're going to say no, we'll say total, and we'll say yes. Awesome. So now we should be able to obtain that information in the front end, and I can pass it to HTML. Let's save this. Let's go back to the front end. Now I should be able to put close model. Once the fetch poll gets executed, I should close the model. So what I can do now, so I can say value, whatever it's passing out of this fetch poll, then I can store this in state, and I can pass it into HTML or any other function. In my case, I can do the following. I am going to pass fetch votes. If you remember fetch votes, that is the function that will show this value right here. So I can pass it there and I can update that now with the real values, okay? Fetch votes, and I'm gonna pass value. I can say value or values because that's an array with no, yes, and total. Okay, I want to say values and done. Now when we fetch votes, this should be the values here. And now I will do the following. I need to obtain the following. I am going to either create an array, a new array, deconstructing this one. So I can say what is the value of yes and value of no. So I can say values, right? If we go back to the array, no will be 0, 1, and 2. So I have to pass 2 first, then 0. Okay, so I'm going to say values 2. This will be values for yes, values. Cool. Now, with that said, I see values already defined. I'm going to say here, I'm going to just change this to be poll value, poll val. Save it and say if poll val is not undefined, then go ahead and run this. This poll val right here, and I'm just going to grab all this and throw it inside here, and boom, we're going to save. Okay, let me give it a shot once again. Connect. It's going to ask me to sign and wait for this. Boom. What do we see? We see 0, total votes 0. Yes, 0, 0, 0. No one has voted. We are golden as far as loading the page with the votes. Now let's build a function to fetch the votes for a particular user and vote those 2 final functions, and we're done. Let's go back here. Now I am going to do a function. The first function that I'm going to do actually is to initiate the voting. So I want to make sure that the user hasn't voted before. So I'm going to tell the user to initiate the session. Then we will check if the user has voted already. If the user hasn't voted already, we will present the buttons to vote. Okay, so let's do that. So let's build that DOM element right here. And I'm going to show you defining an HTML ID and element called show is buttons. Then we will do this DOM manipulation once again to tell the user to click initiate. There's going to be a button called initiate that's going to be generated, and we will invoke get voter. So let's build a function that will call the voter and get me this information so that I can determine if the user has voted yes or no. Okay. And with that said, we are going to build that function right below here. We are building that function in the Soroban JS file. This function is going to be to get the voter information. So I'm going to say async function fetch voter. Okay. And let's start. This time, this function, view voter on the smart contract, requires the wallet address or the account address, which means that I have to convert that to SC. Okay, so I have to convert that to SC val. So I have to use this function right here. Okay, so I'm going to do it. So I'm going to pass caller, right? That's the public key. And now we are going to convert that to SC by just calling let voter account to SC val. We'll pass caller, and that will be converting it to XDR. Now we can define results once again. So I'm just going to take advantage of this. I'm going to copy it. I know that I'm going to be changing quite a few things here. I'm going to call now caller. Then the function is going to be voter. Okay. And the argument, I have to pass it as an array. So I'm going to grab it here. I'm going to pass voter. This is how we pass the values onto that call to view the voter because it's expecting the address. We are going to pass, or we are going to obtain from the smart contract selected, which is the choice that the voter chose when they voted, the time, and that's it. That should be it. Okay, so I'm going to say selected, then I'm going to say time. And if we remember on the function, if I show you the smart contract once again, if you view voter, if I pass it here, the functions, I don't know if you can see it because I'm in the way. I hope that you can. I think that should be good. So what is going to return, that function is going to return selected, the option that was selected, the time, and votes. Okay, so votes we know is going to be 1, but then time and selected are 2 good ways for us to know that the voter voted or not. So we can use that as a condition to then decide if we are going to be presenting the buttons or we are not going to present the buttons. Okay, all right, so that means that selected is going to be the first value, then the second value is going to be time, and the last value, we don't care about the last value. Okay, so we're going to be returning selected and time. Okay, that should give us that information, and we obviously want to export that. So fetch voter, and now we are saving this. Let me go back here, and now I can do this. I can say async function, right? This will be get voter, right? This is the function that we are going to be attaching to that initiate button, get voter, and we are going to obtain that information once again. So I'm going to say let voter info, and we are now going to say await fetch voter here. Okay, let's import that inside here. We should have it right here, and we are going to do this. I'm going to pass what? What am I going to pass? I'm going to pass public key because this will be the caller, right? Beautiful. Okay. And now everything else, you know what? I'm going to grab the information. I'm going to go through it very quick so we don't lose time. I'm going to do this. I am going to show you what's going to happen. Pay attention. So there's a choice button once again. Remember, the first choice button is the same. You can see it's the same for both. What is happening is the following. I am going to be removing the initiate button. This is how we remove that initiate button, and we replace that with either information telling the voter that they voted already or yes or no, 2 buttons. So this is what we're doing, okay? We first have to get rid of that initiate button. This is how we do it. We obtain that element, initiate, which we are declaring here. That ID will be created, initiate, then we can capture that here. We get that element and we remove it, okay? Now, if voter info, remember when we do that fetch voter, the first value in the array is going to be selected. If that value returns none, that means that the user hasn't voted. Okay, which means that now I can provide the user these choices. Okay, so what we can do is we can pass choices. So if we go back here, I need to be able to provide choices. How do we obtain choices? This will be the array that we define in prop data. So if we see here choices, all I have to do is have to make sure that it's here, but we are already importing it because I'm using this for other functions. Okay, so once again, in get voter, I am going to pass choices, then it's just going to display either yes or no. Those are the 2 values inside that choices. Then I am going to create another function to submit the vote. Okay, so that button will be attached to a function that submits the vote, and we pass the option, either yes or no, because this will be an array that will create 2 buttons. Then we append that. This is HTML DOM manipulation, and we create those 2 buttons. Okay, it's very straightforward, similar to what we did not long ago. Now I am going to say if that is none, that means that the user hasn't voted. So go ahead and proceed to create me those buttons and attach the function and all that. Else, then show me voter already submitted. This will be replaced instead of the initiate button. Voted already. This is the caller. And what we are going to pass, voted, and we will pass the option. So the option will be either yes or no. So we will show voted, yes or no, and we will append that to the DOM. Now, with this, I can call that load options. Okay, so how can I do that? Load options will be in the get voter. Let's say, for example, in fetch votes, once this gets rendered, I can update the model. I can say model message, right? And let's say once we get the information about the votes and we display that on screen, we can say connected. That means that the wallet got connected. We can show that animation. We can say also, we can await 3 seconds. This is for me to await 3 seconds, so it shows connected, then 3 seconds, then remove the model. Then we can say load options. So I can pass load options, and now it's going to enable that initiate button. Finally, we can close that model. So we were closing the model before. Now I can just remove it from there and add it here. So I can do this. So where is close model? Close model. Here we go. We can take it out. There we go. And again, the entire file is going to be in the GitHub repo, so you can see it, how everything is breakdown. Okay. And we are just going to return. That will be the end. That looks good. We are still left to submit the vote. So let's build that function. Let's go ahead and do that. So that function will be to submit the votes. It's going to be very similar to this. The only difference is I have to pass that argument. I'm going to build that function to vote. So I'm going to say async function vote, and we pass the value. This will be the value that the user has chosen. So I can say caller, because we still have to pass the public key, and the value, that will be the value that the user chose, either yes or no. And now I can say we are passing let selected. This will be the choice, and we have to convert that to seval or XDR. So I'm going to say string to symbol. That's the function. And we pass value. That will be the string of yes or no. Then let voter, we have to again convert that account to seval. So I'm going to pass that. There we go. And let values, I have to put this on an array. Remember when I pass any data, right? So if I pass voter, I have to encapsulate this in an array. I have to store this in an array. So I have to do the same thing here. So I'm going to say values, once again, going to be equals voter. That will be the first argument that we need to pass onto the function. So if we go back to the function, votes, the first value is going to be the user account, and then the selected, which is going to be the choice, okay? Let's go voter, then the second choice will be selected. That's how we encapsulate the payload, and then we can send that to the smart contract and do the call and vote. And now we are effectively making the call. So I'm going to use that result right here. I'm just going to copy and modify it. Okay, so now we are going to pass what? We're going to pass the caller. Now we are passing record vote. That's the function. And we are passing here the array that I just constructed here. Let's say values. And that should be it, okay? That should send the votes to the blockchain. And we are just going to return results, okay? Beautiful. Now I'm going to export that function, vote, and boom, that's it. Looks good. And again, I don't actually need because we already used that. Now I'm going to say submit vote, right? So we are passing here submit vote. That's the button that will be attached. The function that will be attached to the yes or no will be submit vote and along the actual value, which is either yes or no. Okay. So let's build that function right here. Say async vote, right? And we pass the argument choice, for example. And what do we need to pass? Well, first of all, I'm going to show another model that says executing, right? So we're going to say set model once again, and now we are passing executing that file, executing. So that shows in the screen, PG, right? And now I am going to make sure that I can open the model. So display that animation. And then we are voting. So we are voting and we have to pass the choice. This will be either yes or no. That's the function. That's what it's expecting. And also the caller, which is going to be public key, right? So I'm passing the caller for vote and the choice or the value, whatever the case is. And now we are saying after that is done and we obtain the return that completed, then we say model message and we can say recorded, like vote recorded or something that to tell the user that, you know, your vote was recorded. So I'm going to say recorded SVG. Cool. And we can now say the same thing. I can say await here. Let's wait for 3 seconds. Then now close the model. That closes the pop-up model, and then I can load the page so then it gets refreshed with, you know, the total and whatnot. Okay, so I can say location reload. Okay, that's basically it. Okay, so when we submit the vote, we are going to open the model. We will execute the vote. Like we'll show that on screen that the user knows that the vote has been recorded, and we'll wait 3 seconds, close the model, and reload. This is it. This is it, ladies and gentlemen. Okay, let's test it out. Okay, let me connect. We're gonna connect. Now we are signing to get the information here. Let's wait for that to complete. There we go. There's no votes. Now we get the button to initiate that vote. Okay. When I click here, it's going to check if I already voted or not. If I didn't vote it, we should obtain the yes or no, and we will vote. Okay. Let's initiate. And now it's asking me to sign this transaction to verify that. So it's going to check and boom, we got yes or no. Those will be my 2 choices. Okay. So let's go ahead and vote. I'm going to do yes. Boom. Now it's asking me to execute this transaction. I'm going to review. Now it's telling me a warning because this is a site that's not on the list, like it's not a secure site or whatever. This is just a demo. I'm going to approve and I want to sign the transaction. Vote has been recorded. Awesome. So now we should get that reload. Let's connect the wallet, sign, and wait to see if our vote was counted. There we go. Awesome. So we got the vote. We got a yes. Cool. Let me check my wallet to see if I'm no longer allowed to vote again. So I'm going to say initiate, check, boom, vote already submitted, voted yes. Cool. Now let's switch another wallet. I'm going to use another wallet. Let's see this. Disconnect it. Now I'm going to switch myself to a different wallet. I'm going to use this one. Now let's connect with a different wallet. I'm going to refresh the screen. Connect. Now I'm connecting a brand new wallet. Let's connect, sign, and it's asking me to approve. It's a brand new connection. Boom, connected. And now we can see vote is 1. So there's already a vote. Let's initiate and sign. Now we should obtain the buttons because this is a brand new wallet. Boom, awesome. Okay, now let's vote no. Review, approve, sign. Okay, now it's going to say record it. Look at that. Okay, it's going to reload. Let's connect and see. 50-50, yes or no. Okay, awesome. If I check again, initiate, check if I'm no longer allowed to vote. I am no longer allowed to vote. Voted no. That's it for this video. I hope that you enjoyed this amazing journey working with Soroban Smart Contract. If you do, give it a thumbs up. Subscribe if you haven't subscribed too. And we'll see you on the next video. Bye.